Hi everyone, today's lesson is lesson 54 and it's dividing by multiples of 10. And in a nutshell, today's lesson follows the exact same division algorithm that you've been using for years. It kind of talks through a way of thinking. So just like the lesson says, we're dividing by multiples of 10. And of course, when I say multiples of 10, I mean 10, 20, 30, 40, 50, etc. Just I guess some mindsets around what you're thinking as you're solving these problems. I say this, I guess I say this with a little bit of caution. Don't think too deeply about the methods in this lesson. If we walk through the processes, or if you walk through these processes, and what I'm trying to explain to you is making division like more confusing, or if it's making you frustrated, I don't want you to feel defeated with that. This is really honestly just like, when I say things like good mathematicians think this, good mathematicians are looking for patterns in things, or what have you. That's kind of what the idea behind this lesson is. It's good mathematicians think in this way. But if your brain thinks differently, if you just want to, stick to following your traditional algorithm, that's okay too. I'm telling you that because I don't want you to feel defeated. Either way is okay. This is kind of a shortcut method in thinking about division. Okay, that was a lot of talking. I'll go ahead and get started so this video doesn't become really long. Our learning targets for today are divide by two-digit numbers that are multiples of 10, estimate a quotient using compatible numbers, and then divide dollars and cents by a multiple of 10. This right here is just the division algorithm. You don't need me to spend any time here. It's just the exact steps that we follow when we divide. Here's our first example. The staff arranged 454 chairs in the school gymnasium. Each row of the arrangement contained 30 chairs except for the last row. How many complete rows of chairs were in the arrangement? How many chairs are in the last row? Before we move any further, I want you to think about what this question is asking. This is a multi-step problem. If we really dissect what they're asking us in this case, number one, they're asking us two separate things. Careful mathematicians double check and make sure they know what's being asked of them. The first thing that we're being asked is how many complete rows of chairs are in the arrangement. That's our whole number part of our answer. And then how many chairs are in the last row? That will be our remainder. So they're kind of giving us a heads up already that this isn't going to be a completely perfect quotient, a perfect answer. This answer is going to have a remainder. That last row of chairs is not going to be the same as the others. So when I take a look at a problem like this, I'm going to go ahead, I'm going to pause the video for a sec, just get this set up, and I'm going to talk through how to solve it. Okay, so I have my problem set up. I have 454 divided by 30. Now here's where these mindsets are going to come into play. I have 454 divided by 30. I'm starting to take a look right here at my divisor, my 30. What they're telling you that you can, the way that they're telling you you can think about this is this. Instead of thinking about 30 as a whole, think about this problem by just thinking about this 3 right here. Just forget that it's 30. Just think about 3. 3 and 4, these two numbers right here. If you can do that math, you can do the larger scale math by multiples of 10. So instead of thinking about how many 30s fit in 45, you can break it down to how many 3s fit in 4. Well, one of them fits in 4. But you have to be careful, and this is where it actually got more confusing in my brain. Your brain is programmed to put the 1 right there because we said there's 1, 3, and 4, but now we have to backtrack. We're not talking about 3, we're talking about 30. There is one group of 30 in 4, not 445. So our 1 actually goes here. I hope I didn't lose you there. 1 times 30 is in fact 30. Now we're back to thinking about this as 30. We still need to subtract as part of our division algorithm. 45 minus 30 leaves us with 15 right here. I still have a space left on top in my quotient, so I'm going to bring down my 4. Now our question is, how many 30s fit in 154? But temporarily we can think of how many 3s fit in 15? Let's start there. How many 3s can fit in 15? Well, that's easier to do in my head for sure. 5. Because 3 times 5 is 15. And if I know 3 times 5 is 15, I also know that 5 times 30 is 150. It's 15 with a 0 on the end. And part of the algorithm, we're just going to subtract here, and we are left with a 4. We have filled all of our spaces on top. We've reached the end, and 4 becomes our remainder. Now, we're not going to leave our answer like this. We're going to use labels and remember what they asked us. How many complete rows of chairs? We have 15 complete rows of chairs. I'm going to abbreviate for time's sake. We have complete rows. Complete, yikes, I'm writing with the mouse. Complete, that looks like Ron's. That's going to bug me. I'm sorry. Okay, so we have 15 complete rows of chairs with 4 chairs in the last row. Example number 2. This is an example of where we're going to use compatible numbers to estimate, to get, if we don't need an exact answer, estimating is a really fast way to do it. It's a way for us to incorporate mental math. I miss doing that with you here in the classroom. I think mental math is really important for exercising your brain. So here's an example of how to, use compatible numbers to estimate, to do some mental math. Mr. Gibson had a small grove of 18, I think that's supposed to say young, orange trees that produced 782 pounds of oranges this year. Estimate the average number of pounds of oranges produced by each tree. So the numbers 18 and 782 do not compute very quickly in my head. I don't know about yours, but lucky for us, they used this word right here, estimate. And we can use compatible numbers to work with this really easily in our head. When we look at 18, instead of thinking 18, we can think 20. You know what? I'm going to move that down a little bit. We can think 20. It's pretty close, right? And instead of 782, we can think just 800. Now when I'm looking at these numbers, this is way easier to do in my head. And even easier than this, I can break it down by just looking at the counting numbers. We have a 2 and an 8. So even if you weren't able to quickly think about 20 and 800, you can think about just 2, just momentarily, 2 and 8. Well, how many 2s fit into 8? Well, 2 times 4 is 8. And remember, we don't put it right here, we put it next door, because we're not just talking about 2, we're talking about 20. 4 times 20 is in fact 800, but we could just break that down, or 80, excuse me. 4 times 20 is 80. 20, 40, 60, 80, right? 0 left over. We're going to bring our 0 down, fill the space with a 0. 40 is our answer. Let's make sure we label it correctly. We're talking about pounds. 40 pounds of oranges for each tree. That's pretty cool. All right, 40 pounds. Last example of the day. Taryn bought 20 bread rolls for $4.60. What was the cost of each roll? So in this case, we're doing the exact same process. The only thing that we're doing different is that we've incorporated the fact that this is money. And this is something that you already know. When your dividend, so the number inside the box, when that number is money, the thing that you need to remember to do right away is just bring your decimal straight up. So go ahead and pause your video. I'd like you to give this one a try. I'm going to pause as well, and I'm going to get the problem set up. And before we even start computing to get our quotient, our answer, you can move your decimal and dollar sign up. Unpause your video when you're ready to check your work with mine. All right, so I have my problem set up. I have my dollar sign and my decimal already in place in my quotient. Now I'm just going to divide like normal using the same algorithm and using that trick of just thinking about that counting number part, breaking it down, removing the 0 temporarily to help me get to my answer, to do some more mental math. So really what we're asking right away is how many 20s fit into 4? Well, we know that 4 is too small. 4 is smaller than 20. That space is going to be filled with a 0. Now we can think though, well, how many 20s fit into 46? Well, how many 2s fit into 4? If you are able to think about how many 20s fit into 46, do that. What I'm teaching you today just basically breaks this down a little bit further. Some of you, that will be really, really helpful, and some of you won't find that necessary. Either way is okay. So either you're thinking right now, how many 20s fit into 46, or how many 2s fit into 4? And if you think about it like that, well, 2 2s fit into 4. And remember, we're not writing it right here because we're actually thinking about 20. We're going to write it right here. 2 2s fit into 4. Now, back to thinking about this like 20. 2 times 20 is 40. And part of our algorithm is to subtract. 46 minus 40 is 6. I have a space left to fill here. I'm going to drop my 0. Here again, you can think about this question as how many 20s fit into 60, or how many 2s fit into 6. Either way is okay. Either way, we have the answer would be 3. So 3 groups of 2 will fit into 6, or 3 groups of 20 will fit into 60. And my brain loves when things work out evenly. That is indeed 60. And our remainder is 0, which works out great when we're talking about money. 23 cents was the